Hello, and welcome to my video tutorial. Today, I'll be guiding you through the writing of a Matlab script that can fit a curve to a set of data that can allow you to correlate that data to physical models and extract useful information. I've generated this fake data set with some error, not unlike something you would see in a laboratory setting. We'd like to plot this data instead of just staring at a list of numbers, but before that, we need to perform a couple of preliminary steps. First of all, we'd like to tell Matlab what our working directory or folder is. We do that by clicking the Browse for Folder button here and selecting the appropriate folder. I've done this beforehand, and you can see that our current folder is the one containing our data. We import this data by clicking Import Data under the Home tab and opening our file. We can now rename these variables. I'd like to call them X and Y, and it's recommended that you import them one at a time as such. Note that our variables X and Y are now under our workspace window. This is just a fancy way of saying a collection of variables. We can save this workspace for later use by typing the command save, open parentheses, single quote, and then our file name. I'll just call it data.mat. Close your single quotes and your parentheses, and after hitting enter, you'll see that data.mat is saved in the current folder. Start a new script by hitting Ctrl on your keyboard or by hitting New Script under the Home tab. It is common practice to type the commands COC, clear, and close all in order to clear the command window, clear the workspace, and close any open figures. This is done so that Matlab has a clean slate to work with every time you run the script. However, since we did use that clear command, we're going to have to load our workspace into the script. We can do that by typing load, open parentheses, single quote, and then our workspace file name, data.mat. Open a new figure, say figure 1. We can now plot X versus Y. However, I like to add an extra argument, R+, that tells Matlab that I want my data points to be plotted as red pluses. Run your script by hitting F5 on your keyboard or by hitting Run under the Editor tab. Since this is your first time running a script, you're going to have to save the file. Call it something like curvefit.m. We can see that our data looks like a sine function, which has the following general form. Notice that our wave height, C1, appears to be about 5. C2, our period, the time it takes to complete one full cycle, appears to be about 10. And our horizontal and vertical offsets appear to be about 5 and -1. To find a new function, ds, as a difference squared between f and y. The idea is that as these constants become closer and closer to the ones that best fit this curve, ds of x will get smaller and smaller and eventually reach a minimum. Luckily, Matlab has a function fminsearch that can use these approximations to calculate the exact values that minimize ds. I skipped ahead and wrote the Matlab function ds. However, I've included in the video description a download for every file I've used. That way, you could read through these comments that I left if you want to have a better understanding of what's going on behind the scenes. All that's left to do is to minimize ds using fminsearch and plot our results. We can do that by typing c equals fminsearch at ds and then our initial approximations, which was 5, 10, 5, and -1. To plot our curve on the same figure as our data set, we must type hold on. We could do this by typing fplot at our variable x, and from here we could simply copy and paste from ds. One additional thing is required, and that is the range of this function. We could see from our figure that our function ranges from 0 to 30. Running once again, we can now see this blue curve that very nicely fits our data set, with the exception of a few points, but this is due to that error I generated. And there you have it. The exact constants are shown here below. If you run into any problem or have any questions, feel free to leave a comment below. Thank you for watching, and happy coding.